In this video, we're going to find the area of one petal of the given three-leaf rose. In order to do this, I'm going to have to identify one of the petals according to the theta values which produce it. Let me explain that. So here's the idea. Let's say we start with theta equals 0. Well, it puts us right here on the petal. As theta increases, notice that r is decreasing. It's decreasing down to 0. It's actually going to become negative at this point, causing a reflection out of the first quadrant into the third. Now r is it's increasing in magnitude or in absolute value. Now it's decreasing in absolute value. It comes back to 0. And it keeps doing this. Keeps ending up back at 0, increasing or decreasing to 4 or negative 4, and then coming back to 0. So to identify a petal, it'd be a good idea to solve the equation r equals 0, or in this case, obviously, 4 cosine of 3 theta equals 0. So let's do that. So let's find some solutions to this equation. When is the cosine 0? Well, there are infinitely many possibilities. Let's write down a few. Certainly at pi over 2. Then again at 3 pi over 2. 5 pi over 2. I could keep going forever in that direction if I wanted to. Let's go in the other direction. How about negative pi over 2? And then before that would be negative 3 pi over 2. Basically, what I need are two adjacent solutions to this equation. And I'm not quite finished yet because I haven't solved for theta. I've got 3 theta, so let's solve for theta. So theta, negative pi over 6, pi over 6, 3 pi over 6, which is pi over 2, 5 pi over 6. These are some of the solutions. Basically, as theta ranges between any two adjacent solutions of the original equation, one petal is traced out from beginning to end, from the origin back to the origin. For example, when theta is equal to negative pi over 6, which is this angle right here, r is 0. As theta increases, r increases until we reach 0, in which case r is 4. And then as we continue on, theta is still increasing, but r is decreasing back to 0. And notice that happens when theta is equal to 2 pi over 6. So might as well focus on this petal right here. How do you find the area of the petal? Well, you integrate from negative pi over 6 to pi over 6. Oops. One half r squared, which is r is 4 times cosine of 3 theta. That's your r, so it's 1/2 r squared d theta. Well, let's clean that up a little bit. Oops, it's not going to work. This is the integral from negative pi over 6 to pi over 6 of, okay, now I've got 4 squared which is 16, and then 1/2 in front, so that's 8. And then, of course, I've got cosine squared 3 theta. Well, how do we integrate even powers of cosine? And hopefully you remember that we use a power reduction formula. In this case, that would be cosine squared theta. Let's say cosine squared A is equal to 1 plus cosine of 2A divided by 2. Or in this case, cosine squared 3 theta equals 1 plus cosine of 2 times 3 theta, which is 6 theta, over 2. So we're integrating from -6 to 6, negative pi over 6, excuse me, to pi over 6. It's a plus. 8 times 1 plus cosine of 6 theta over 2 d theta. Now immediately we see, we've got 8 divided by 2, so that's 4. Let's take care of that. Let's pull that 4 out in front, and we're integrating still from negative pi over 6 to pi over 6. The function we're integrating now is 1 plus cosine of 6 theta d theta. When you integrate the constant function 1 with respect to theta, you get theta. When you integrate cosine of 6 theta with respect to theta, you get 1/6 sine of 6 theta plus an arbitrary constant, which we don't need. We do have limits of integration, negative pi over 6 to pi over 6. By the way, you could have integrated, if you wish to, cosine of 6 theta by making the u substitution u equals 6 theta. Then, of course, du would be 6 times d theta. It's your choice. Let's go ahead and multiply, distribute the 4. So we have 4 theta plus 4/6, that's 2/3, and then sine of 6 theta. And our bounds are negative pi over 6 to pi over 6. So first we evaluate at pi over 6. And we get 4 times pi over 6, which is 2 pi over 3. Plus 2/3 times the sine of 6 times pi over 6. Well, 6 times pi over 6 is pi. And good news here, sine of pi is 0. Then we subtract what we get when we evaluate the same expression at negative pi over 6. So it's going to be 4 times negative pi over 6, which is negative 2 pi over 3. Damn this stylus. Plus 2/3 times the sine of 6 times negative pi over 6. That 6 times negative pi over 6 is negative pi. Good news. Just like the sine of pi is 0, so is the sine of negative pi. So basically this stuff is gone. And what we're left with is this, 2 pi over 3, whoa, minus negative, so plus another 2 pi over 3, which is 4 pi over 3. And that is the area of one petal of the given 3-leaf rose.